Thanks for watching this video. This is Mr. Bowman, and in this video we're going to share with you factoring trinomials in a slightly different form. Okay, in our last video we learned a little bit about how to factor trinomials. Remember, factor means to write as a product, as a multiplication problem. Trinomials that look a little bit like this, and you learn to do it using the box, which is a really nice setup for this problem because it models the multiplication that's happening. It's the setup we used to multiply polynomials. But there's a difference in the polynomials, the trinomials rather, that we're going to share with you in this video. In the last video, all of the leading terms, all of the first terms of the trinomials were just x squared or n squared. And in this video, we're going to show you how to factor ones that don't have a 1 as that coefficient. This polynomial is 3x squared plus 14x plus 8. So let me still think about putting 3x squared in the upper left. Let me think about fitting the positive 8 in the bottom right. And I still want to think about, like we did in the last video, what my options are for ways to multiply two numbers and get positive 8. I could use 1 and 8, or I could use 2 and 4. The difference here, though, is that when I work on 3x squared, I can't just use x and x. I'm going to have to think about how to multiply numbers together to get 3x squared. It helps that the only option in this example, the only two whole numbers you can multiply to get 3 are 1 and 3. So in this example, I think that I can say that one of them must be 3x, and the other one must be x. It would be a different case if there were two other options for whole numbers we can multiply to get the coefficient, like 3 here. So what I need to think about now, and it does involve a little bit of trial and error, is which of these pairs do I need to use, knowing that one of the numbers goes here in the very top right, and one of the other numbers goes here in the very, very bottom left. Remembering that whatever I put here is going to have to be multiplied by 3. And I'm looking for a way to add and get 8. So let me just model the idea that this truly is guess and check. Let me try using 1 and 8. Let me try putting the 1 here and the 8 here. Would that get me to 14x? 3x times 1 is 3x. 8 times x is 8x. Those don't add up to 14x, do they? Let me erase it and try plan B. Maybe I've got them in the wrong order. Maybe the 8 belongs here, and the 1 goes here. Does that work? 1 times x is just x. 3x times 8 is 24x. Those don't add up to 14x either. Rats. So that tells me I don't think it's the 1 and the 8 at all. Let's try using the 2 and the 4. And let's see. What if we put the 4 here and the 2 here? This would be 6x. This would be 4x. That doesn't add up to 14x either. Well, let's try it by putting the 2 here and the 4 here. Does that work? 3x times 4 is 12x. 2 times x is 2x. You know what? That's the one, isn't it? That's the one that would get me these two here, just like in the last video, to add up to 14x. That's what I need. And I need them both to be positive. I need a positive 2 and a positive 4. So now, once I've got the outsides figured out, I know what my two factors are. 3x squared plus 14x plus 8 can be written as 3x plus 2 times x plus 4. And just like we did in the previous work, I can check my answer by multiplying those two binomials back together. But check it out, the work's right here. We've got it. Okay, here's another example. Let's see if we can use our box to factor the trinomial 2x squared plus x minus 15. Might be a helpful thing to remember that plus x really means plus 1x, doesn't it? So whatever I need, whatever is going to play out here I'm going to have to remember that what's in this box plus what's in this box is going to have to add up to just 1x. Okay. So just like in the previous example, I do know that the 2x squared belongs in the upper left corner. I know that the negative 15 belongs in the bottom right corner. If I think about what goes here and here to multiply and get 2x squared, again, I've got the advantage of knowing that there's only really two numbers you can multiply together to get 2, and that's 2 and 1. So I'll put 2x here, and I'll put 1x, just x, right here. Now when it comes down to negative 15, my options to find 15, what can you multiply and get 15? Well, there's 1 and 15, or there's 3 and 5. Now I'm going to have to be mindful of the idea here that the signs of these two numbers have to be different. That's the only way I'm going to get negative 15. So it could be negative 3 and positive 5, or it could be 3 and negative 5, or it could be 1 and negative 15, or negative 1 and 15. So I'm going to have to just not be afraid to do some trial and error here. Let me try using the 3 and the 5. Let me try putting the 3 here and the 5 here. What will that get me in the two open spots in the box? Well, 3 times x is 3x. 2x times 5 is 10x. One of them is going to have to be negative. So if I subtracted 10x and 3x, I don't get 1x, do I? That's not it. Maybe we can try it the other way. Put the 5 in the bottom left and the 3 here. One of them is going to have to be negative to make it negative 15. Can we make that work? 2x times 3 is 6x. 5 times x is 5x. I think that works. Can you tell which one of those needs to be negative? To get positive 1x, I need negative 5x and positive 6x. So that tells me I need negative 5 here and positive 3. And we've got it. Our factorization, our answer, this trinomial in factored form, is 2x minus 5 times x plus 3. Okay, let's look at one more example, and this one is 6x squared minus 7x minus 20. Now there is something different about this example. Can you tell what it is? I do know that the 6x squared belongs here. I know that the negative 20 goes here. The difference is that there's not just one way to multiply two whole numbers and get 6. I'm going to have to consider that there might be a couple of different options for the first term as well. This first term, to multiply and get 6, I could use 1 and 6, or I could use 2 and 3. So I don't even know what necessarily goes in the first spot, here and here. I've also got options for 20. I could use 1 and 20. I could use 2 and 10. Or I could use 4 and 5. And I know the signs will have to be different to get negative 20. Folks, I can't really sugarcoat this. This is just a little bit of guess and check and trial and error. Let's just try it out. Let's pick a set. Let's try the 2 and the 3 here, and the 4 and the 5. There's a lot of different ways this could play out. Let me put 2x and 3x. You know, I knew the 2 and the 3 would be the split for 6, but the way to split up x squared is to get x and x. Let me just try putting the 4 here and the 5 here. I don't know if this is going to work or not. We'll see. 2x times 4 is 8x. 5 times 3x is 15x. One of them has to be negative. Oh, how about that? That's the one, isn't it? If I made one of these negative, I could get negative 7x. Which one needs to be negative? It's the negative 15. Negative 15 plus positive 8 is negative 7. That's the one I need. So I lucked into that one. Got that one on the first try. I need negative 5 here and positive 4 here. And the factorization that I need to write for my answer is 2x minus 5 times 3x plus 4. Thanks for watching.